Hello everyone, I would like to begin by acknowledging the traditional custodians of the land on which we meet today, the Wurundjeri people of the Kulin Nations, and pay my respects to their elders past and present. I extend this respect to Aboriginal and Torres Strait Islander peoples here today. This is the first of perhaps 2 videos for this week which covers the core learning material for week 1 of HEA 10002. So let's get started. Firstly, here is my email address on screen. If you need to reach me, please feel free to email me. Also, if you'd like to keep up to date with my research, please feel free to follow my Twitter handle, which is also on screen here. So let's jump into the formal content. So this unit is an introductory unit to health science. So we'll begin by providing some foundational definitions. What is health? How can we define this concept? Well, the definition of health is contested, meaning there are many, often conflicting definitions or meanings. Lowell Lewin once described the task of defining health as similar to trying to shovel smoke, a metaphoric way of saying it's really difficult. Why is it difficult? Because it's an abstract concept like love or beauty. But one definition I offer is that on screen, which is perhaps the most well-known definition, and it comes from the Constitution of the World Health Organization. And it reads, "Health is a state of complete physical, mental, and social well-being, and not merely the absence of disease or infirmity." We could critique this definition for being overly utopian. Who here has ever experienced complete physical, mental, and social well-being, especially in a pandemic? But what it does, and what our discussion of health in this unit seeks to do, is it seeks to broaden the discussion from a singular focus on disease, or the absence of disease, to a more holistic discussion of well-being. What is health science? Health science is an applied science, meaning it's something that we do in a systematic and principled way. In this context, we are referring to the systematic and principled way we obtain evidence to solve healthcare problems and investigate health issues. And of course, the way that we do that is through the scientific method. So let's begin thinking through the complexities of health. So a question to contemplate here is health a simple or a complex concept? So let's look at overweight and obesity as a health issue in which we can really explore this in a preliminary way. We live in a health-obsessed era. We are bombarded with messages from health authorities, health professionals, fitness and diet gurus to do this and not do that. We are urged to take individual responsibility for our health every single day, with the blame often placed on people who fail to uphold or meet these standards. But if we look at the factors that increase the chances of people being overweight or obese, which for context 67% of Australian adults are, they are complex factors. Adults from low socioeconomic positions are more likely to be obese due to lacking access to opportunity for exercise. Financial struggles can affect one's ability to afford a healthy diet and can cause food insecurities. Where you live can be a determining factor. Adults living in regional and remote areas have higher obesity rates than those in major cities. Certain kinds of jobs also affect times for meal planning and self-efficacy. So as you can see in discussing those determinants, albeit briefly, health is a complex phenomenon. So the take-home message there is that health is complex, it's multifaceted, and it's inherently political. Your challenge in this unit is to think critically to unpack the underlying issues and determinants of health and well-being. There are several key learning outcomes that we will be working toward obtaining during the duration of this unit. These include, for instance, I'll just cover the first one, to demonstrate academic skills, the ability to work collaboratively and to communicate. So this will be evident during our scheduled classes and in your participation on the discussion board, which I will monitor. A full list of the learning outcomes is provided in the syllabus. Please make sure you jump into the discussion board this week to reflect upon the full suite of learning objectives. This is your activity 1.2 for this week. Returning to the topic of health science and perhaps your future role as a health scientist if you choose this path. Health scientists use evidence to ensure that health systems and population health systems are addressing the health issue and the underlying determinants. Health scientists work across a variety of disciplines. I've just captured a few of these on the screen. These disciplines can span from epidemiology to health promotion to nutrition to family health. Health scientists use the scientific method. We employ and want you to be savvy at navigating the scientific method of research. It's a particular standard of evidence that is considered to be reliable and rigorous enough to inform treatments or the ways we deliver healthcare and conduct health science research. Some notes on how the method affects health delivery are on screen. The scientific method is used to conduct research, producing evidence that aims to improve the delivery of health services. This may alter such things as treatments provided to patients, improve their experiences in the health system, improve diagnoses, drug therapies, and cost effectiveness. The scientific method aims to ensure that health services are based on the best available scientific and clinical evidence. A key learning objective in this unit is for you to demonstrate your ability to make judgments about the quality of evidence on which healthcare, health research, or trends in health science is based upon. So to start, we need to ensure that we are all across some basic terms and particular research methods, which is what we will cover in the remaining period of this first lecture. Let's begin with the distinction between a theory and a hypothesis. The example I will use relates to studies of social support. So social support is the phenomenon or concept with which I'm particularly focused on in my PhD. Social support refers to the degree to which you feel you are surrounded by people who provide emotional, instrumental, and informational care. So social support typically refers to sources of support that are informal, friends, family, a significant other. There is a theory of social support called the stress buffering hypothesis that states that while stressful life events such as grief, loss, or illness, or perhaps being in a pandemic, will result in negative outcomes in terms of one's health and well-being, social support can lessen the association between stress and feeling terrible. Or, as the name suggests, social support buffers against a decrease in health and well-being, which is something that this pandemic has really brought to light. So the stress buffering hypothesis is in fact a theory, which is a bit confusing. So perhaps we'll say the stress buffering model is a theory. Broadly speaking, I will summarize the theory as follows. The stress buffering hypothesis posits that social support protects individuals from the pathogenic consequences of exposure to stress. But this, in its current form, isn't something we can test. A hypothesis, rather, is more directive. It would be something like this. Higher perceived social support is associated with lower perceived stress among adults during stage 3 lockdown. A key feature of a hypothesis is that it needs to be able to be proven wrong. That is, it must be falsifiable. There are a range of additional key terms that I encourage you to ensure that you have a solid understanding of. One practice may be to start a glossary of key terms in your exercise book if you're using one, or among your subject files on your computer. Write your understanding of these terms in your own words. This will be a really useful preparation task for your exam in this unit. We will just continue working through some of these key terms now across the next 2 slides. Observation. So on screen it reads, observations, recording phenomena in a precise, unbiased manner, needs to be able to be replicated by other scientific investigators. So you need to ensure that the effect that you have observed is owing as much as possible to the thing that you've manipulated or changed in research, rather than, say, measurement error. Whoops, I jumped ahead there, sorry. Description is the second one on screen. Translating observations into descriptive statements that can be understood by others. For example, if you're measuring distance, use a system of measurement that makes sense to your audience. For instance, you would use meters and not yards if you're here in Australia. I'm going to jump down to generalization. Often a critique, particularly of quantitative research, is how generalizable the findings are. Do these results only apply to adults? Do they only apply to white adults? Do they only apply to cisgender adults? These are the critical questions that you must ask when reading academic pieces and when you're integrating research into your work in this unit. But generalization, as it says on screen, is an extension of the concept to less specific criteria. If an observation suggests a possible pattern or relationship, a generalization may be made to inform and direct future research. For instance, if you observe something in a sample of 10, you may conclude that it does apply to a larger population if that sample is representative of that population. Induction. Induction refers to a particular type of logic, inductive logic. It's a form of thought, where you start with something you've observed in the field and then you seek to make sense of it by way of generating a theory. So, for instance, if I notice that a lot of my trans and gender diverse friends are having a really tough time during COVID, I may seek to look to literature to better understand why social isolation is most profoundly felt among socially marginalized groups in this pandemic. Induction is different to deduction. In deductive logic, you start with a theory and then you seek to observe the phenomenon. Hypothesis is appearing again here on this screen, so the fact that it is appearing twice is perhaps an important hint for quizzes. Make sure you're across the defining features of a hypothesis.